Hello guys, welcome to the machine design world. This is Keval Patil, and in this video we're going to see few problems related to design of bolted joint using PSG. Last video we have done the introduction of bolted joint and also seen first case of the bolted joint. In that case we have derived few equations, and those equations we're going to use today for problems. We will start with the first problem. The problem reads, the structural connection shown in figure below is subjected to an eccentric force P of 10 kN. So it is having eccentric force P of 10 kN with eccentricity of 500 mm. Eccentricity of 500 mm from the center or CG, center of gravity. The distance between first and second bolt is 200 mm. And between first and third bolt is 150 mm. All the bolts are identical. Permissible shear stress is 80 megapascal. So permissible shear stress is 80 megapascal. So what is given? P is given 10 kilonewton, 10 into 10 raised to 3 Newton. Eccentricity 500 mm. Tau permissible is 80 megapascal, is nothing but 18 in Newton per mm square. Now we will see what is this R1, R2, R3, R4. We know this diagram. We have seen this diagram in last video. If you guys haven't seen the last video, please go in the description. There you will find link for the last video. Now first we have to find this radius. Okay. For that see, we want this CG. We have in this radius as R2 and this distance. Okay, I want to find this R2. This is theta. I know this distance. This is given as 150. This is given as 150. So I can say this distance is 150 by 2, that is 75. All right, and this distance, that is this distance, so it is 200. So this distance is 100. So I can find R using Pythagoras theorem. So I'm just drawing the same diagram over here. Theta, R, 75 and 100. So here also it is same. Okay, it is 75, it is 100. Here also it is 75 and it is 100. 100, 75. So R is equal to, R1 is equal to, R3 is equal to, R4 is equal to same. So I'm telling R is equal to R1 is equal to R2 is equal to R3 is equal to R4, and R is equal to under root 75 square plus 100 square. So it is nothing but, if you calculate, you will get 125 mm. So we have used Pythagoras theorem over here to find R. So now we know R. We will go to the next step. But before that, just understand this diagram. We having bolt 1, 2, 3, 4. You can name any. You can give 1, 2, 3, 4, however you want. In last video, I think we gave name like 1, 2, 3, 4. So I'm giving you 1, 2, 4, 3. Now which bolt carrying highest load? You don't have to find all the stresses on every bolt. Okay, you don't have to find the stresses on all bolts. Okay, what you will do, you will find the stresses which is acting on heavily loaded bolt. Now which is heavily loaded bolt? So in last video also we saw that right side bolts are heavily loaded. You can see this, they are having same direction, downward direction. They are having this downward direction. Here one is down and one is upward direction. One is down and one is upward direction. So remember that if this is CG and this is axis, and load is acting at right side, then bolts which are on this axis, y-axis, or right side of the y-axis will carry highest load. This load is acting here. This is y-axis. So bolts which are on the axis. Let's guess here, one more bolt here, one more bolt here. So on the axis or right side of the axis will carry highest load. So you have to find which bolt is carrying highest load. For now 2 and 4 is carrying highest load. Both having same angle theta in between, so both having same value. So we'll go to the step first, that is primary shear stress. Finding primary shear load. Primary shear load. Okay, so we know what is primary shear load. Now I'm just considering this bolt 2 as a carrying highest load. So I will mention, okay, over here bolt 2 and 4 carries highest load, or you can say like bolt 2 and 4 are heavily loaded. So force primary 2 is equal to total force F divided by number of bolt. So we have 10 into 10 raised to 3, okay, P value upon N is, this is F or P, whatever you can take, okay, upon number of bolts are 4. So you will get 2500 Newton. So you got force on heavily bolted load 2 and 4. So FP2 and FP4 are same. Okay. Now next is secondary shear load. Secondary shear load. Okay. So what is secondary shear load? The formula for secondary shear load is, so we want force secondary on second bolt is equal to P or force F. Okay, I will make it F eccentricity into R2 divided by R1 square plus R2 square plus R3 square plus R4 square. R1 square plus R2 square plus R3 square plus R4 square. Okay. So this R1, R2, R3, R4 are same. So I can write it is nothing but F E R2 upon 4 R1 square or 4 R square. Okay. So now this value is same. Okay. So the value will be F is 10 into 10 raised to 3, eccentricity 500 mm, R2 we found out 125, and 4 into 125 square. So you will get after calculation. You will get value as 10,000 Newton. Right. So now we are having primary shear stress, we are having secondary shear stress on primary shear load and secondary shear load on bolt 2, which is heavily loaded bolt. Now we have to find resultant shear load. So resultant shear load is equal to F2. Okay. So we know the vector addition formula, that is F2 is equal to F primary on bolt 2 square plus F secondary on bolt 2 square plus 2FP2 Fs2 cos theta. Now we want to find cos theta. Okay, so here only you just find cos theta. When you find R, that time only find cos theta. It will be good. The cos theta is nothing but adjacent upon hypotenuse. Adjacent is 100, hypotenuse is 125, it is 0.8. Okay. So it will be equal to 2500 square plus 10,000 square plus 2 into 2500 into 10,000 into 0.8, and you will get the value as 12,093 Newton. Now you know the resultant shear stress. You can find the bolt size. There are two methods to find the bolt size. We will use both the method. The first is tau max. So tau max is equal to maximum shear stress or permissible shear stress is equal to maximum force upon cross section area. Now just find the cross section area. So tau max is 80 given, F2 we know 12093 upon AC. Now find the cross section area. AC will be something 151.16 mm. So this is first method. Now go to the PSG page number. PSG page number 5.42. Okay, go to the course series. Okay, go to the course series. Here you will find stress area. In this last column you will get stress area. Now how much area we got? 151.16. So 151.16, just search in this area, take one area. Okay, so it is 84.5 and we having 151, so it is next to this and before this. So always you can't select 84.3, select greater value. So 151.16. So next value is 157. So this is the required area. Now go here and select M16 bolt. So using PSG, so you can say using PSG 5.42 M16 bolt is selected. Okay, now see the outside diameter M16, so outside diameter is 16, so D is 16 and DC is, this is minor diameter of bolt, DC is 13.54 C. DC is 13.546 mm and D is 16 mm. So this is first method, and the second method is same formula you will use, but instead of AC you will use you can use same formula. So tau max is equal to F2 upon AC. Now here 80 is equal to 12093 upon pi by 4 DC square, and find DC. Okay, find DC. You will get DC as 13.87 mm. Okay, so now how to find D? So D is DC upon 0.8. This is empirical relation. So it is nothing but you will get 16.93. So you can say 17 mm. Then too you have to select the standard bolt size. When to use this method? When this area value, you can see the area value, you have to select the course series, and the maximum value of the bolt is M16, so it is 817. So sometime this area you will find it is over this 817, so you won't have any bolt over here. In that case you have to use this method to find DC and D. Alright, in that case this is not possible because we are not having that area is above this 817 mm square value, so we won't get single bolt. So in that case you have to use this method. Otherwise this method you in exam you use this method only the case in which area is beyond this 817 value, that time only use this method. Alright, so we will move to the next sum. So this is a second question on case 1, which reads, find the diameter of bolt for the arrangement shown in figure. So this is the arrangement. Okay, assume for the material of bolt sigma yield 350 megapascal and factor of safety 3.5. So this is the arrangement. 40 kilonewton load is acting over here. We having 4 bolt, but slightly different arrangement. Earlier it was 1 2 3 4, right? We had bolt here, and now we are having here. Okay, bolt 1 and 3 having 150 mm distance among them, and here also 150 mm distance, and this is 300 mm eccentricity. Now they are having same distance among them, so I can say they are having same radius. Okay, now what will be the radius for bolt 1? It will be 75, right? For bolt 2 75, 75, 75. So we are having all radius, all same radius, we can say 75, 75, 75. Alright. So we will start with given. So what is given? Eccentricity 300 mm. Load F is equal to 40 kilonewton is equal to 40 into 10 raised to 3 Newton. Sigma yield given 350 megapascal. It is nothing but 350 Newton per mm square. Factor of safety given 3.5. Okay, so first thing we're going to find is, we know the sigma yield and factor of safety. We know the bolt material. For bolt we use ductile material, usually mild steel. So ductile material, then which theory we are going to use? Maximum shear stress theory. So according to maximum shear stress theory, tau max or tau permissible is nothing but 0.5 of sigma yield upon factor of safety. So it will be 0.5 into 350 divided by factor of safety 3.5. So you will get the answer like 100 into 0.5, so 50 Newton per mm square. Okay, this is similar to, this is sigma y upon factor of safety is nothing but sigma t. So tau is nothing but 0.5 of sigma t, so 0.5 of sigma t, it is 50 Newton per mm square. Alright, then what is radius? Radius r is equal to r1 is equal to r2 is equal to r3 is equal to r4 is equal to 75 mm. We are having same radius throughout for all bolts. Okay, now see which bolt carrying highest load. So bolt is at right side, load is at right side, so this is the axis. So bolt which are on axis and right side of the axis will carry highest load. So now see, we are having 4 bolts over here, 4 bolts over here. For primary load will be acting downward. Just take this load at CG, and that load will be F upon number of bolt. So it will act downward like this. So this black one is FP, that is acting downward. And secondary load acts perpendicular to the radius in the direction of load. So perpendicular to the radius in the direction of load. So this is the radius for this is the radius. Okay, so this is the radius and perpendicular to the in the direction of load. So you will get here. For this perpendicular and in the direction of the load, so you will get this. Perpendicular in the direction of load, this. Perpendicular in the direction of load, this. So this is a secondary load. So now you can see over here, this load is positive. I'm just considering downward load is positive, so this one is negative. So no, you don't have to consider this. We have to consider the bolts which are acting on this axis, which are lying on this axis, and which are right side of this axis, because load is at right side. Okay, so we have to consider this 3 load. These 2 bolts having similar radius, so load which are acting on this bolt is same. It is having 90-degree angle, it is also having 90-degree angle. So secondary load acting on this bolt is same, and you can say total load is acting on these bolts are same. Okay, so this first bolt and second bolt, I'm just considering first bolt and second bolt as heavily loaded bolt, and we have to find load acting on these bolts. Okay, so now first thing is primary shear load. So primary or direct shear load also you can say shear load. Okay, that is FP. So FP1 is equal to FP2 is equal to F upon number of bolt. So F is given as 40 kilonewton, 40 into 10 raised to 3 divided by number of bolt. So it is equal to 10 into 10 raised to 3 Newton. So we got the primary load. Now we will find secondary shear load. So secondary shear load on bolt 1, okay, FS1. Now see, we are having same radius. What is the formula? Formula is F into E into radius upon, or R1 upon R1 square plus R2 square plus R3 square plus R4 square. Now all the bolts having same radius, all the bolts, so secondary shear load will be same on the all bolts. So it will be equal to F, that is 40 into 10 raised to 3, eccentricity, that is 300, R is same, that is 75 for all bolts, we calculated over here, okay, and then 4 into R is same, so 4 into 75 square. We have seen this last sem. Now this FS1, FS2, FS3 will be same, so I am saying FS1 is equal to FS2. I am just finding for 2 bolts, okay. So it will be, just do the calculation, you will get 533.33 into 75 is equal to, you will get something 40 into 10 raised to 3 Newton, something you will get. So this answer is 533.33 and this is 75, so 40 into 10 raised to 3 newtons. Okay, so now you got secondary load on bolt 1 and 2. 3 and 4 also having same secondary load and same primary load. So loads acting on every bolt is same, are same. Loads acting like primary and secondary. Primary load also, see, FP1, FP2, FP3, FP4 having same load. Okay, and secondary load also we are having same load because the radius is same. Now we have to find maximum load on bolt 1 and bolt 3. Okay, or resultant load you can say. Resultant load on bolt 1. Just now resultant load. Resultant load. So resultant load on bolt 1. Okay. Now see, in case of bolt 1, there is no angle between the primary and secondary load. Okay. This is FP1, this is FS1, this is FS2, this is FP2. Okay. So you can say there is no angle between primary load and secondary load. Then we don't have to go for vector addition in angle formula. Okay, we had that formula cos theta fp1 square plus fp2 fs1 square plus 2 fp1 fs1 cos theta. That formula we don't have to use because there is no angle between this. So vector addition method, when we having angle, we use that formula. We are not having angle, so we can directly add these two forces. Okay, so now we will get fp1 plus fs1. So what is fp1? 10 into 10 raised to 3. What is fs1? 40 into 10 raised to 3. So we'll get 50 into 10 raised to 3 Newton. Now for bolt 2, F2 we will have to use vector addition formula, that is under root fp2 square plus fs2 square plus 2 fs1 fp2 fs2 cos theta. We know the cos theta is 90, cos 90 is 1. Now cos 90 is 0, so this whole term will become 0. So you will get under root 10 into 10 raised to 3 square plus 40 into 10 raised to 3 square. If you calculate, then you will get 41.23 into 10 raised to 3 Newton. Now you can clearly see F1 having maximum load, so resultant load on F1 is maximum. Okay, now you don't have to calculate this. I will make you understand why. So you having this diagram, you know that bolt 1, 2, 4 will carry highest load. If the radius of both the load, if the radius of this and this is same, in that case you don't have to calculate this. You don't have to calculate this. This will be less than F1 if radius of this and this is same. If radius of this and this bolt is same. If they having different radius, then you have to calculate this. Okay, then you have to calculate this. Now we having same radius for this and this. This is 75, this is also 75. Then definitely bolt 1 will carry higher load. Okay, so we come to know the highest load. Bolt 1 is carrying highest load. We know that tau max is equal to F max upon area. So what is F max over here? 50 into 10 raised to 3, right? Tau max given 50. We calculated it as 50. Here we calculated it 50 Newton per mm square. Okay, divided by cross section area. From here you can find cross section area, that is 1000 mm square. Now 1000 mm square is not in PSG. 5.40. Okay, you can check over here. It is not in 5.40. 817 is maximum. So now you can't use PSG, so you have to use normal method, that is pi by 4 dc square is equal to 1000. So from this dc is equal to 35.58. okay, so dc is, you know the relation between dc and d, and you can find d using 35.58 divided by 0.8, that is, so I will write the relation d is equal to dc upon 0.8. okay, so from this you can find d, and d will be 44.47. So we are done with the problem. Now we don't have to write like selecting M30 bolt, M36 bolt. We can select only when they are in the course series, that is 5.42. We are just done with the problem. Okay, so now we will move to the case 2. We will see case 2 and case 3 in next video. For now we are done with the 2 problems of case 1. Hopefully you have understood the problem. Thank you.